Welcome to the lecture of research methodology. In this lecture, I'm going to discuss with you about methods of data collection. My name is Wilson Yong. I am a senior lecturer at the Biotechnology Research Institute, University Malaysia Sabah. First of all, I would like to introduce to you the concept of data collection. Data collection is the process of gathering and measuring information on variables of interest in an established systematic manner. Data collection enables us to answer stated research questions, test hypotheses, and evaluate outcomes. While the methods of data collection vary by discipline, the emphasis on ensuring accurate and honest collection remains the same. The goal for all data collection is to capture quality evidence that then translates to rich data analysis and allows the building of a convincing and credible answer to questions that have been posed. Regardless of the field of study or preference, accurate data collection is essential to maintaining the integrity of research. Therefore, both the selection of appropriate data collection instruments and clearly delineated instructions for their correct use reduce the likelihood of errors occurring. The precise form of a statistical analysis often depends on whether data are qualitative, ranked, or quantitative. To determine the type of data, focus on a single observation in any collection of observations. Generally, qualitative data consists of words such as yes or no, letters Y or N, or numerical codes 0 or 1 that represent a class or category. Ranked data consists of numbers, for example, first, second, or third, that represent relative standing within a group. Quantitative data consists of numbers that represent an amount or a count. For example, the weight reported by 36 male students in Table 1 are quantitative data, since any single observation, such as 160 pounds, represents an amount of weight. If the weight in Table 1 had been replaced with ranks, beginning with a rank of first for the lightest weight of 133 pounds and ending with a rank of 36 for the heaviest weight of 245 pounds, these numbers would have been ranked data, since any single observation represents not an amount, but only relative standing within the group of 36 students. Finally, the Y and N replies of students in Table 3 on whether they have a Facebook profile are qualitative data, since any single observation is a letter that represents a class of replies. To clarify further the differences among the three types of data, let's introduce the notion of level of measurement. Looming behind any data, the level of measurement specifies the extent to which a number or a word or a letter actually represents some attribute, and therefore has implications for the appropriateness of various arithmetic operations and statistical procedures. In general, there are three levels of measurement: nominal, ordinal, and interval or ratio, and these levels are paired with qualitative, rank, and quantitative data, respectively. The single property of nominal measurement is classification. That is, sorting observations into different classes or categories. Words, letters, or numerical codes reflect only differences in kind, not differences in amount. If people are classified as either male or female, or coded as 1 or 2, the data are qualitative and measurement is nominal. When any single number indicates only relative standing, such as first, second, or third place in a horse race or in a class of graduating seniors, the data are rank and the level of measurement is ordinal. The distinctive property of ordinal measurement is order. Comparatively speaking, a first-place finish reflects the fastest finish in a horse race and the highest GPA among graduating seniors. Although first place in a horse race indicates a faster finish than second place, we don't know how much faster. On the other hand, the distinctive properties of interval or ratio measurement are equal intervals and a true zero. For example, weighing yourself on a bathroom scale qualifies as interval or ratio measurement. Equal intervals imply that the difference between 120 and 130 pounds represents an amount of weight equal to the difference between 130 and 140 pounds, and it's appropriate to describe one person's weight as a certain amount greater than another person's. A true zero signifies that the bathroom scale registers zero when not in use, that is, when weight is completely absent. Since the bathroom scale possesses a true zero, numerical readings reflect the total amount of a person's weight, and it's appropriate to describe one person's weight as a certain ratio of another's. It can be said that the weight of a 140-pound person is twice that of a 70-pound person. This figure illustrates an overview of the measurement scales. Given some set of observations, decide whether any single observation qualifies as a word or as a number. If it is a word or letter or numerical code, the data are qualitative and the level of measurement is nominal. Arithmetic operations are meaningless and statistical procedures are limited. On the other hand, if the observation is a number, the data are either rank or quantitative, depending on whether numbers represent only relative standing or an amount or count. If the data are rank, the level of measurement is ordinal, and as with qualitative data, arithmetic operations and statistical procedures are limited. If the data are quantitative, the level of measurement is interval or ratio, or approximately interval when numbers represent non-physical characteristics such as intellectual aptitude, psychopathic tendency, or emotional maturity, and a full range of arithmetic operations and statistical procedures are available. Data can be obtained from primary as well as secondary sources. Many researchers obtain their data from secondary sources because these data provide the information needed, are easy to collect, and time-saving. The differences between primary and secondary data are represented in a comparison format in this slide. Primary data is original because these are collected by the investigator for the first time, while secondary data are not original because someone else has collected these for his own purpose. Primary data are more reliable and suitable for the inquiry because it is collected for the particular purpose, but secondary data are less reliable and less suitable as someone else has collected the data, which may not perfectly match to the inquiry of the investigator. Collecting primary data is quite expensive, both in time and money terms, while secondary data requires less time and money, so it is economical. Primary data are in the form of raw materials, while secondary data are in the finished form. However, the possibility of personal prejudice exists in primary data, but lesser degree of personal prejudice in secondary data. This chart represents some of the methods for primary data collection, and the methods can be further classified into quantitative or qualitative data collection methods. Quantitative methods are based on mathematical calculation using various formats like closed-ended questions, correlation, and regression methods involving measurements, while qualitative methods are associated with elements that are not quantifiable and do not involve any mathematical calculations. Survey is most commonly used method in social sciences, management, marketing, and psychology to some extent. Survey can be conducted in different methods such as questionnaires, polls, interviews, and Delphi technique. Experiments require a setting in which to perform logical study to collect data. Experiments are more suitable for medicine, nutrition, and for other scientific studies. In laboratory or field experiments, the experimenter has to keep control over the influence of any extraneous variable on the results. Observation method is used when the study relates to behavioral science. It can be done while letting the observing subjects know that they are being observed, or without letting them know. Observations can be made in natural settings as well as in artificially created environments. Interviews are primarily done in qualitative research and occur when researchers ask one or more participants general, open-ended questions and record their answers. Interviews can be conducted via face-to-face or online conversation, mail or telephone communication. Lastly, focus groups are also a primary format for qualitative data collection. This is a type of research that seeks open-ended thoughts and feelings from respondents, as opposed to quantitative research that involve numerical-based data collection. A focus group typically consists of around 6 to 12 people who share similar characteristics or common interests, engage in a discussion with a facilitator or moderator. Aside from consulting the primary source, data can also be collected through a third party, a process common with secondary data, which is a type of data that has already been collected in the past. A data classified as secondary for a particular research may be said to be primary for another research. This is the case when a data is being reused, making it a primary data for the first research and secondary data for the second research it is being used for. Secondary data may either be published data or unpublished data. Usually, published data are available in various publications of the local and foreign governments or of international bodies or their subsidiary organization. Government census, like the population census, agriculture census, and so on. Technical and trade journals, books, magazines and newspapers, reports and publications of various associations connected with society, business and industry. Reports prepared by research scholars and universities in different fields, public records and statistics, and historical documents, and other resources of published information. The sources of unpublished data are many. They may be found in diaries, letters, unpublished biographies, and autobiographies, and also may be available with scholars and research workers, trade associations, and other public or private individuals and organizations. With the advent of electronic media and the internet, secondary data sources have become more easily accessible nowadays and requires very little research or manpower to reuse these resources. In order to ensure the accuracy of the sampling process, appropriate sampling techniques must be used. Sampling techniques are scientific methods of selecting samples from populations. As far as possible, the samples selected must be random and representative of the population from which the samples are selected. Sampling techniques can be broadly classified into two categories: non-probability sampling techniques and probability sampling techniques. In a non-probability sample, individuals are selected based on non-random criteria, and not every individual has a chance of being included. This type of sample is easier and cheaper to access, but it has a higher risk of sampling bias, and you cannot use it to make valid statistical inferences about the whole population. Non-probability sampling techniques are often appropriate for exploratory and qualitative research. In these types of research, the aim is not to test a hypothesis about a broad population, but to develop an initial understanding of a small or under-researched population. On the other hand, probability sampling means that every member of the population has an equal chance of being selected. It is mainly used in quantitative research. In general, researchers prefer to use probability sampling techniques to ensure that their findings are valid, as well as to allow them to make inferences on the population. If you want to produce results that are representative of the whole population, you need to use a probability sampling technique. There are four types of non-probability sampling. Convenience sampling is probably the most common of all sampling techniques. With convenience sampling, the samples are selected because they are accessible to the researcher. Subjects are chosen simply because they are easy to recruit. This technique is considered easiest, cheapest, and least time-consuming. For example, an interviewer may look for respondents at a shopping complex, an airport, or a stadium to conduct the interview for sampling purposes. Judgmental sampling is more commonly known as purposive sampling. In this type of sampling, subjects are chosen to be part of the sample with a specific purpose in mind. With judgmental sampling, the researcher believes that some subjects are more fit for the research compared to other individuals. This is the reason why they are purposefully chosen as subjects. The researcher selects a respondent whom he feels possesses certain characteristics that represent the population of interest based on his experience. Snowball sampling is usually done when there is a very small population size. In this type of sampling, the researcher asks the initial subject to identify another potential subject who also meets the criteria of the research. This procedure is applied until the researcher obtains the required number of respondents. However, the downside of using a snowball sample is that it is hardly representative of the whole population. Quota sampling is a non-probability sampling technique wherein the researcher ensures equal or proportionate representation of subjects depending on which trait is considered as basis of the quota. The researcher observes the specific characteristics of potential respondents before making a selection. The procedure is similar to convenience sampling, except that the number allocated for each group of respondents with specific characteristics are based on population statistics. For example, if basis of the quota is college year level, and the researcher needs equal representation with a sample size of 100, he must select 25 first-year students, another 25 second-year students, 25 third-year, and 25 fourth-year students. Of the probability sampling, simple random sampling is the easiest form. All the researcher needs to do is assure that all the members of the population are included in the list and then randomly select the desired number of subjects. There are a lot of methods to do this. It can be as mechanical as picking strips of paper with names written on it from a box while the researcher is blindfolded. Or it can be as easy as using a computer software to do the random selection for you. This technique is similar to a lottery system in which the winners are selected from a pool of participants without bias. In systematic sampling, samples are systematically selected based on a fixed range. The range acts as the interval for choosing the samples. Say for example, you are in a clinic and you have 100 patients. The first thing you do is pick an integer that is less than the total number of the population. This will be your first subject, for example 3. Next, select another integer which will be the fixed range or interval between subjects, for example 5. Then your subjects will be the patient 3, followed by 8, 13, 18, 23, and so on, every fifth individual from the first subject. Stratified sampling is also known as proportional random sampling. This is a probability sampling technique wherein the subjects are initially grouped into different classifications such as age, socio-economic status, or gender. Then, the researcher randomly selects the final list of subjects from the different strata. It is important to note that all the strata must have no overlaps. Researchers usually use stratified sampling if they want to study a particular subgroup within the population. It is also preferred over the simple random sampling because it warrants more precise statistical outcomes. Cluster sampling is done when simple random sampling is almost impossible because of the size of the population. Just imagine doing a simple random sampling when the population in question is the entire population of Asia. In cluster sampling, the researcher first identifies boundaries. In case of our example, it can be countries within Asia. Then, the researcher randomly selects a number of identified areas. It is important that all areas or clusters within the population be given equal chances of being selected. The researcher can either include all the individuals within the selected areas, or he can randomly select subjects from the identified areas based on a probability sampling technique, such as simple random sampling. There are several reasons why it is important to adhere to ethical standards in conducting research and data collection. First, ethical standards promote the aims of research, such as knowledge, truth, and avoidance of error. The standards prohibit against fabricating, falsifying and misrepresenting research data to promote the truth and avoid error. Since research often involves a great deal of cooperation and coordination among many different people in different disciplines and institutions, ethical standards promote the values that are essential to collaborative work, such as trust, accountability, mutual respect, and fairness. Many ethical norms in research, such as guidelines for authorship, copyright and patenting policies, data sharing policies, and confidentiality rules in peer review, are designed to protect intellectual property interests while encouraging collaboration. Most researchers want to receive credit for their contributions and do not want to have their ideas stolen or disclosed prematurely. Many ethical standards also promote a variety of other important moral and social values, such as social responsibility, human rights, animal welfare, compliance with the law, and public health and safety. Funders more likely to fund research projects if they can trust the quality and integrity of research. Ethical lapses in research can significantly harm human and animal subjects, students, and the public. For example, a researcher who fabricates data in a clinical trial may harm or even kill patients. And a researcher who fails to abide by regulations and guidelines relating to radiation or biological safety may jeopardize his health and safety or the health and safety of other colleagues and students. Given the importance of ethics for the conduct of research and data collection, it should come as no surprise that many different professional associations, government agencies, and universities have adopted specific codes, rules, and policies relating to research ethics. The following is a rough and general summary of some ethical principles that various codes address. Honesty. Strive for honesty in all scientific communications. Honestly report data, results, methods and procedures, and publication status. Do not fabricate, falsify or misrepresent data. Do not deceive colleagues, granting agencies, or the public. Objectivity. Strive to avoid bias in experimental design, data analysis, data interpretation, peer review, personal decisions, grant writing, expert testimony, and other aspects of research where objectivity is expected or required. Avoid or minimize bias or self-deception. Disclose personal or financial interests that may affect research. Integrity. Keep your promise and agreements. Act with sincerity. Strive for consistency of thought and action. Carefulness. Avoid careless errors and negligence. Carefully and critically examine your own work and the work of your peers. Keep good records of research activities such as data collection, research design, and correspondence with agencies or journals. Openness. Be open to criticism and new ideas. Share data, results, ideas, tools, resources. Respect for intellectual property. Honor patents, copyrights, and other forms of intellectual property. Do not use unpublished data, methods, or results without permission. Give credit where credit is due. Give proper acknowledgement or credit for all contributions to research. Never plagiarize. Confidentiality. Protect confidential communications, such as papers or grants submitted for publication, personal records, trade or military secrets, and patient records. Responsible publication. Publish in order to advance research and scholarship, not only to advance one's career. Avoid wasteful and duplicative publication. Responsible mentoring helps to educate, mentor, and advise mentees or students, promote their welfare, and allow them to make their own decisions. Respect for colleagues. Respect your colleagues and treat them fairly. Social responsibility. Strive to promote social good and prevent or mitigate social harms through research, public education, and advocacy. Non-discrimination. Avoid discrimination against colleagues or students on the basis of sex, race, ethnicity, or other factors that are not related to their scientific competence and integrity. Competence. Maintain and improve your own professional competence and expertise through lifelong education and learning. Take steps to promote competence in science as a whole. Legality. Know and obey relevant laws and institutional and governmental policies. Animal care. Show proper respect and care for animals when using them in research. Do not conduct unnecessary or poorly designed animal experiments. Lastly, human subjects protection. When conducting research on human subjects, minimize harms and risks and maximize benefits. Respect human dignity, privacy, and autonomy. Take special precautions with vulnerable populations and strive to distribute the benefits and burdens of research fairly. With that, I would like to end this presentation. I hope you enjoyed the topic. Thank you so much for joining me and participating in this lecture. Thank you.